for today is Quadratic Functions 8.2. We're going to talk about zeros of quadratic functions. A zero of a quadratic function is an x value that makes the function equal to 0. So when is y 0? Basically, it's the x-intercept of the function because x is something and y is 0. To find the zeros, you have to check where the graph crosses the x-axis. Because it's a parabola, this can be in two different places, it can be in just one place, or there can be no zeros. Let's look at an example. Here's a parabola, and we see that the zeros where the graph crosses the x-axis is in two places, at -5 and at -1. So -5, 0 and -1, 0. Here's another one. We see here that we only have one 0. The parabola only crosses the x-axis at one point, at 5. So basically 5, 0. In a final example, we see that there are no zeros. Though this graph crosses the y-axis, it does not cross the x-axis, therefore there are no zeros. Every parabola has an axis of symmetry. Just the way it sounds. It divides a parabola into two symmetrical halves and it passes through the vertex of the parabola. You can find it in two ways. Number one, if a function has one 0, like I showed you in the previous slides, use the x-coordinate of the vertex to find the axis of symmetry. If a function has more than one 0, use the average of the two zeros to find out what your axis of symmetry is. And now I'm going to show you some examples. Here's one. So first thing you want to do is find out what your zeros are. So here, my parabola passes through the x-axis at 2 and at 5. So because there's two zeros, this means my axis of symmetry is the average of the two. So 2 plus 5 is 7, divided by 2 is 3.5. And that looks like where it would be perfectly broken right in half. So here is my axis of symmetry at 3.5. Let's look at another one. Here, I first have to find my zeros. It looks like I only have one, -2. And because of that, I use that as my axis of symmetry. That's where the graph is symmetrical in two halves. So the axis of symmetry is also -2. And you can see that cuts the graph in half perfectly. Now you will try one on your own. So remember, start by finding the zeros and using them. Pause the video here. You should notice that you have two zeros here, 1 and 5. And because you have two zeros, this means you need to take the average of the two to find the axis of symmetry. Well, 1 plus 5 is 6 divided by 2 gives us 3. And you can see this here at exactly 3. We have a perfect half. Now there's a question. What do we do when we don't have a graph and we just have an equation? There has to be a way to find the axis of symmetry. So there's a formula we can use. To mathematically find the axis of symmetry without a graph, you can use the formula -b divided by 2 times a. Here's an example. The equation is y equals x squared plus 3x plus 4. And we're looking for the axis of symmetry. Take a minute and jot this down. So first I have to find the value of b and I have to find the value of a in this equation. We see that b is 3 and a is 1. Now we can plug this into the equation. -3 over 2 times 1. 2 times 1 is 2, so I have -3 over 2, making my axis of axis of symmetry, -1/2, -1.5. Let's look at another example. Find the axis of symmetry when your equation is y equals 2x squared plus x plus 3. Pause the video here. So you should have seen that b equals 1 and a equals 2. So we're going to use the formula -b divided by 2 times a. So we get -1 divided by 2 times 2, which equals 4. -1/4 equals -0.25. And now sometimes we have to go backwards and use the axis of symmetry to help us find the vertex of the graph. Here are the steps for doing so. To find the vertex of a parabola, you can first find the x-coordinate of the vertex by finding the axis of symmetry by using zeros or the formula. To find the y-coordinate, substitute the x you got in step 1 into the function, and then you can write the vertex as an ordered pair. Here's an example. I need to find the vertex using the equation y equals x squared minus 4x minus 10. If I find the axis of symmetry, I know where it goes through the x-axis. So now what I need to do is find the y-point. So we can use the formula -b over 2a to find the axis of symmetry. Because b is -4 and now it's -b, I have -4 divided by 2 times 1, which is a. 2 times 1 is 2, and -4 is +4. 4 over 2 gives me 2. So my x is 2. To find the y-coordinate, I'm simply going to plug into my formula or my equation 2 to figure out what y is. So y equals 2 to the second power minus 4 times 2 minus 10. 2 squared is 4. -4 times 2 is -8 minus 10. 8 minus 8 is 0 minus 10 gives me -10. Therefore, my coordinate in step C is 2, -10. And that would be the vertex of this parabola. Pause the video here as you will try y equals 5x squared minus 10x plus 3 and find the vertex of this graph. For the axis of symmetry, -b over 2a first, you have -10 divided by 2 times 5, which is a. 2 times 5 is 10, and -10 we can simplify to +10 as our numerator. 10 divided by 10 equals 1. X equals 1. Now what I have to do is substitute into my equation, and you should have said 5 times 1 squared minus 10 times 1 plus 3. That simplifies to 5 minus 10 plus 3. 5 minus 10 is -5 plus 3 gives us -2. And your coordinate of your vertex is 1, -2. You have just finished 8.2. Look over your notes and you will decide if you would like a practice level or a challenge level practice worksheet. If you would like help or you have any questions, make sure you ask me.